Hello students. In the last video, we were talking about the basic concepts of project scheduling and tracking, and here we are going to talk about the relationship between people and effort which is required for project scheduling and tracking. In small software development projects, a single person can analyze requirements, perform design, generate code, and conduct tests. And as the size of a project increases, more people must become involved in it. That is, suppose an effort required to complete a project is 10% year effort. Then we can rarely afford the luxury of approaching a 10% year effort with one person working for 10 years. So, definitely, more people must be involved in larger projects. Okay, so then we have a feeling that if we fall behind the schedule, we can always add more programmers and catch up later in the project. Unfortunately, adding people late in a project often has a very bad effect on the project, causing schedules to slip even further. That is, the people who are added must learn the system first, and the people who teach them are the same people who were working in that project. So, while teaching, no work is done and the project falls further behind. So, the time taken for learning is one of the problem, and also another issue is more people increases the number of communication paths and the complexity of communication throughout a project. So although the communication is absolutely essential to successful software development, every new communication path requires additional effort and therefore additional time. So, with this, you can understand that the relationship between the number of people working on a software project and the overall productivity is not linear. So, we can demonstrate the highly non-linear relationship between chronological time to complete a project and human effort applied to the project. The number of delivered lines of code L is related to effort and development time by the equation L equal to P into e raised to 1 by 3 t raised to 4 by 3, where E is the development effort in person months, P is a productivity parameter that reflects a variety of factors that lead to high quality software engineering work, which range from 2000 and 12,000, and T is the project duration in calendar months. This equation can be rearranged as E equal to L cube by P cube t raised to 4, where E is the effort expended in person years over the entire life cycle for software development and maintenance, and T is the development time in years. This equation for development effort can be related to development cost by the inclusion of a burdened labor rate factor. Okay, so that's about the empirical empirical equation for relationship between the people and effort. Now, talking about the effort distribution, a recommended distribution of effort across the definition and development phases is often referred to as the 40-20-40 rule. That is, 40% of all effort is allocated to front-end analysis and design, and a similar percentage is applied to back-end testing, and the rest 20% is used for coding. With this, you can correctly infer that the coding is de-emphasized. So, this effort distribution should be used as a guideline only. That is, the characteristics of each project must dictate the distribution effort. The work expended on project planning rarely accounts for more than 2 to 3% of an effort unless the plan commits an organization to large expenditures with high risk. And then requirement analysis may comprise 10 to 25% of project effort. Effort expended on analysis or prototyping should increase in direct proportion with the project size and complexity. And a range of 20 to 25 percentage of effort is normally applied to software design. Time expended for design review and subsequent iteration must also be included in this, or should also be considered. Because of the effort applied to software design, the code should follow with relatively little difficulty. Okay. And a range of 15 to 20 percentage of overall effort can be uh, achieved for coding. Then testing and subsequent debugging can account for about 30 to 40 percentage of software development effort. This is how usually the effort is distributed in a project.